So today we're going to talk about setting up data-driven test cases with Java tools. And so I'll start with, well, this is the agenda that we'll cover today. So what is the current state of testing? We'll give a list of a few tools that hopefully you may aware of some of this. If not, this is the place to learn new things. A particular database software that we're going to use that can be applied for anything actually. We'll have a live demo, and at the end, I'll have a list of resources for you. We're encouraged to ask questions at any time if you want to. Of course, we'll have time at the end of the session also if you want to have questions. I'll be here also for the rest of the day until Friday if you want to grab me outside also to have any kind of questions or comments. So I'm going to start with a little bit of story time, and this is mostly about what happened to me about 15 to 16 years ago, and some of these may have happened to you as well. We'll see. So back in the day, again, we're talking about 16 years ago or so, I had to work with a particular piece of software that required a database. Now, this database was running on a very, very old machine, and a machine that no one really wanted to touch. It was hidden somewhere in a back room that not that many people knew where it was. And this thing broke down every so often, at least once a week. So I heard this particular piece of software, I had to make it work. So one of the earliest problems that we have with this is that we only have access to that particular instance, the production instance, but we needed a way to test out new features. So provisioning a new test instance for this database was a lot of pain. I could not use the real production instance. I could not touch that particular piece of hardware unless I just needed to upload a new version of the software that needed to run. There was no one else, the IT department, that could help me set up this particular thing. So it was a lot of pain. Back in the day, it was kind of easy to install MySQL or Postgres. You just download a zip, uncompressed, boom, up you go. And then obviously you can use package managers. But the particular software that I was using at the time was Oracle Express Edition. So installing it was not as easy as the others, and certainly setting it up wasn't also that easy. So I had an issue on how to get started with that thing. And this is about the time when CI/CD, or at least CI servers, started to become a thing, right? So the problem now that even if I managed to get an instance of a particular version of the software running for my own users, if I had some other team member that had to run their test cases, I would have to share that instance. The problem is that if we both are running test cases against this instance, we will need to agree when we have to do this. Otherwise, we're going to step into each other. And if we compound in a CI server, then we cannot run our local test cases when the CI server is running the same thing. Otherwise, we're going to step into each other. And that just starts to make things much more complicated. So we needed to find a way to ensure that when I wanted to run my own test cases, that I have access to a given instance of the database, and the same goes for our team members and the CI server and whatnot. So back in the day, again, 16 years ago, this wasn't easy. Nowadays, we have things way, way easier, and we'll see in a moment. So obviously, there were a lot of questions about that. How am I going to make this happen? If I don't have access to that production system or that production hardware, how am I able to install that? Do I need to talk to someone on the IT department and say, hey, can you install this given version of the database? And then 3 months later, I will get an answer, hey, here's a version of the database, which is not the one that I requested. I don't have access to admin rights and whatnot, so I cannot change anything, right? That was back then. And hopefully that doesn't happen to you anymore. So we have to deal with these things. Say that we're able to go across this hurdle, that we're able to solve the issue. Now we have some version of the database that we can access to and we can admin to. Okay, and we'll figure out what to do with the sharing and stuff. But the next thing is, how do you set up that database at the right state when you need to run your test cases? Because one thing is to say, hey, here's a particular version of the schema, but is it the right version of the schema? Does it have the right tables and columns? Does it have the right data? Do you need different sets of data for all the different test cases that you need to run? Are you going to supply all that data whenever you want to run certain test cases? And once you have done that, how do you verify that the modifications you made at the data are correct? Because if we use the same facilities provided by the application, we are trying to test the application itself. So that's not a good thing. If we use the framework, or if we use any frameworks to build the applications, we kind of rely on that facility. For example, we could use a Spring Boot. We're using a Spring Data. But if there were to be any issues or bugs or problems with the implementation of that version of Spring Data or Spring Boot, we will have to wait for the next version to hopefully have a fix for that. It would be better if we could go as close as possible to the database to do this kind of assertions, right? We need a very thin layer, abstraction layer on top of the database so that we can verify that the data that we're modifying, updating, deleting is the right one. So for that, we also needed something to do. So that was me 6 years ago trying to figure out all these different things. And I was able to find solution for some of those, specifically for seeding the data. I was not able to get a solution for provisioning the database. I simply had to get another computer that told my people, my team, to touch it. This is one single instance that we're going to use for testing. We will figure out how we're going to share it. And that's how it went. Luckily, my team wasn't that big. But if you're working in a big company, in a big organization, you probably have lots of people working on the same product. That would be a problem. But in order to solve these issues, what we have to do is just apply the right set of tools. Now we do have them. So I hope that most of you know what Testcontainers is. So who knows what Testcontainers is? Just a few hands. Okay. This is one of those technologies that changes your life for the better. So one of the things that I would like you to take home after this session is have a look at Testcontainers. What is Testcontainers? It's basically a library that allows you to run any kind of software that it's capable of to be packaged inside a container. Now, Testcontainers has a set of, they call it modules, but basically there will be dependencies where they package the minimum configuration required in order to run a particular piece of software. For example, do you need a given database, whether it's Postgres, MySQL, Oracle, or you need Kafka or RabbitMQ, something else? There will be modules for all these software that this piece of software that I mentioned, and the way that you configure that in your projects, whether it's Maven, Gradle, what have you, is very easy. The next thing is, how do you set up the containers where you need to expose certain ports or credentials or URLs? That's done very easy also through programmatic APIs. The third one is the lifecycle. This is the important one. This is the primary reason why Testcontainer exists, which is if we want to run at least one container, someone has to start that container at some point. We know that containers take some time to start and be ready. So we run health checks, scripts, and whatnot. Someone has to do this. And once the container is up to date and is ready, then we can run the test cases. And after all the test cases have been run, whether successful or not, these containers have to be reclaimed. They have to be garbage collected. Otherwise, we will be running problems with memory leaks. So the Testcontainers library takes care of that life cycle for us automatically. We will simply have to say, I want this image for this particular container to be run, and boom, it happens. You can also have dependencies within containers. For example, you could have a load balancer container in front of RabbitMQ or a database or some other kind of software. And you will programmatically define that you want one container to have a dependency on another, and the life cycle will take care of instantiating the containers in the right order for you. So you simply have to define your dependencies in between, and boom, that happens. So Testcontainers is pretty good. But obviously we're here because we are Java developers. We're mostly Java developers, I suppose. Anyone here uses Go, Python, Rust, JavaScript? The good thing about Testcontainers is that it also works with these other languages. So if your main language happens to be Java and you make use of Testcontainers and find it good, and you suddenly switch to another language, or you find your other teammates using other languages, they can also benefit from the behavior provided by Testcontainers. Okay. So in terms of developing Java applications, I guess It's all over the place. We have one of the things that we have in the Java ecosystem is a lot of choices. I will assume that most of you use Spring technologies, Spring Boot, Spring MVC, Spring Data. Who uses Quarkus? No hands. Any Jakarta Enterprise, Jakarta Microprofile, Headed On, Macronaut, something else? No frameworks? Okay, yes. So that's what kind of expected. So not that many hands for the others, because the Spring Boot happens to be the dominant player in the market. Whether you use or will use Hibernate without a Spring. At some point, some people thought that a Spring framework was just a configuration layer for Hibernate, because that's the only reason why you will use a Spring back in the day. So in terms of writing test cases, I will hope that everybody writes test cases right now, right? Is it true? We don't go to production without writing test cases? Great. And I hope that most of you use JUnit 5 now. Is anyone still using JUnit 4? There may be some valid reasons for JUnit 4, but I'm happy to see that all of you use JUnit 5. Perfect, because you're using modern features from Java. That's good. By the way, when you see a QR code on the slides, that's a shortcut for the URL for the particular technology or thing that I'm showcasing in the slides. Great. So JUnit 5 is pretty much the standard now. Testcontainers supports JUnit 5, so that's a good thing. And this will be the beginning, the starting for us to just getting writing test cases. But this does not help us solve the second problem that we had, which was seeding the database. So Testcontainers will allow us to provision the instance, database instance, whenever we're ready. Because the other thing that we could do, and this is something that was done also in the past, is that let's see what I can say about Testcontainers. So instead of having a database instance running already in an existing server and telling people do not touch it because I'm going to run my test case on that one, you could tell your build tool, Maven, Gradle, what have you, to create a local instance of the database as part of the build before all your test cases are run. So in that way, you could automate a little bit as part of your build pipeline. But the problem with this is that, well, you have to figure out how to run that particular instance of the database using Maven or Gradle or what have you. And you have to ensure how to run it, how to configure, wait for that thing to be up and ready. And once all your test cases are run, whether it's in sequence or parallel, you also have to be in charge of shutting down that database correctly, right? So doable, yes, but it's a little bit of work that we had to manually do. Testcontainers says you don't have to do that. We will take care of that. And as a matter of fact, we will do even better so that the instance will be started right before any test case. And you can have multiple instances running in parallel if you want to. And once the test case is done, regardless of how many test methods you have, whether green or red, then the database instance or the containers actually will be shut down gracefully for you. So that assures that you have a pristine environment for every single test case that you want to run. It's even better. It's all managed for you. So, okay, that takes care of provisioning. How about seeding the database? Well, there is a project called DbUnit. It has existed for a long time. This is the one that I found back then to set up the state for the database. This project provides two main features. One is to put data into the database. You can set that data using programmatic API, or you can use external resources, whether it's, there are two XML formats. And I say XML because this project was started close to 20 years ago. I know there are a lot of young people here, but back in the day, XML was all the rage. So we did XML all over the place, and that's why we hate XML. But so they chose XML because that was the format of the times. And you can see the data, and you can also verify the data regardless of what ORM if you use, whether it's Hibernate or Spring Data or JPA, or it doesn't matter where it is. You can grab a set of that particular piece of data that you want and do a diff in memory, pretty much as you would do a assert in JUnit. And the other thing that this thing does is allows you to export the data. in the given format supported by DbUnit, so you don't have to manually write the data sets that will be sent as an input or as an output for verification. Yet, it only works for the JUnit 4. But obviously, most of you now are using JUnit 5. We would like to use JUnit 5 constructs. So there is an extension to DbUnit called DbRider, or it started as an extension, but now it's a project on its own, to bring DbUnit into the modern world, into JUnit 5. And they added more and more features to it. So we will see both of them. And depending on the types of test cases that you're running, you may want to go with one version, which is a bit more manual work. And DbRider composed with a Spring Boot will make it things to run in a much simplified way. Okay. So in terms of database software, these technologies work for pretty much any database, whether it's MySQL, Postgres, SQL Server, Oracle. They also support NoSQL kind of databases. DbUnit, I don't think so, but at least Testcontainers does. So Testcontainers doesn't care about what kind of database or software you want to run. As long as you can have it on a container image, it's good to go. So in this case, you could use any database you want to. I want to showcase the Oracle database for a few reasons. Well, obviously because I employ Oracle, but because there's very likely the chance that you will have to work with this database. And in the past, it has been very troublesome to set it up. How many of you have tried to install an Oracle database? Was it an easy thing? No, it wasn't, right? How many of you installed Postgres or MySQL? Was it that easy? It was, right? Would you like to have the same ease of installations in Oracle? Yes, of course, but how can we make that happen? So that's why I'm here. One of the things that I would like to say about the Oracle database, not just because I'm an Oracle employee, but as a developer, this is pretty good. We have this thing called the Convergent database. That's the name we chose, but other database vendors call this the multi-model approach, which allows you to run multiple data formats inside the same database engine. So Postgres does it, MySQL, SQL Server, even Mongo does it. In our case, we support relational, which is what Oracle is well known for, but we also support documents, JSON, graph, spatial, even vectors, because everybody's crazy about AI these days. So all these different formats, I believe that Oracle is the one that provides the most formats in the same database. And the good thing about this is not just that you have access to all these formats, you can use one single query language. You can use SQL to query across all those formats. So if you have a document table or a set of documents that you want to create a projection of some JSON properties alongside some relational columns and some graph or even vectors, you can do so without having to go one level up into the application layer. You can certainly do that, but then you have to figure out how to work with the different drivers and conversions for the formats, for each one of those formats and blah, blah. Yes, we can do that. It will take more effort, but it's doable. So in the case of Oracle, we do this at the database level. There are free tools that you can connect to the database. We support pretty much every programming language. There is no-code solutions like Apex, which is based on JavaScript. We have command line tools. There's a lot of things that you can have access to. But how do you install it? How do you use it? There is a version of it on the cloud. It's called Autonomous Database. If you are able to use cloud options, then I will suggest to have a look at this one. There is an option to run this database for free. If you sign up for the Oracle Cloud, the version is called the free tier, always free tier. You sign up for this one, and you have access to 2 instances of the database, a few compute instances in Intel and ARM, a load balancer, a few set of free resources, which I will have to say that sadly for the competitors, this is truly always free. Those resources will never be charged. Other competitors will give you like a 12-month free access, and they will start to charge your credit card. We won't. That is not the case. If you like to use other resources that are not part of the free tier, then you will have to pay for those, obviously. Now, there is a free version of the database that you can run on-premise as well. It's called Oracle Database Free. This version was released, in April, exactly 2 years ago, first for developers, as a developer access. This is the first time the company does this for the database. So they really want to take us developers into account to make sure that we have access to these technologies beforehand. And then 1 year later, so that was in May of 2024, so last year, it was released as GA for everybody else. Now, you can run this on Linux, you can run this on Windows, and since November of last year, you can also run it on ARM. So if you have a machine like this one, like a Mac, you can also run it natively on it. You can run it on containers as well. The containers that you see here in the official Oracle Container Registry, this you require a license. But the containers that you have here at the bottom, there's one for the autonomous database here, and the one there at the bottom is the free one that you can use. Now, even though these are the official images, if you want to use them for, I forgot to mention, you can use this database for testing, for development, and for production for free. No questions asked. Now, so obviously you can use that particular instance, that container instance with test containers. There is a little bit of a problem with this particular image. It takes 3 minutes to start because it's quite big. It's 9 gigabytes of download. So if you want to run this all the time with test containers, for those of you that know test containers, this is gonna take a while. Yeah, that doesn't seem like a very good idea. You can use it for production on containers. That's not a problem because maybe bootstrap time is not an issue. But for testing, it is. Can we do better? Yes, we can. There is another set of images available at this particular URL. And we start with version 23 and onward. The latest version is 23.7, released like a month ago, I believe. And these particular images are layered. They take about 900 megabytes. So it's less than 1 gigabyte. The other was 9 gigabytes. And the boot up time is about 10 seconds. Comparison, Postgres starts in 1 second on containers. So from 180 seconds to 10, that's pretty good. We still have 9 more seconds to go in order to be comparable to Postgres in this regard. But it depends on your settings. You can boot your database with an external volume so that the data resides in an external directory. So that may make your database start a little bit faster. And there are different ways that you can configure this. This is, of course, for the latest version of the database, 23 AI onward. If you need to run previous versions of the database from 11 to 21, then there's another set of images, Oracle XC, that you can make use of. And these are also pretty slim. They start pretty fast, also close to 900 megabytes layer. They start within the 10 to 20 seconds. So this is pretty good. Now, you may be asking, well, you show us some official images from Oracle, and now we're seeing some images coming from a GitHub repository. And that doesn't say Oracle there, that the organization is some G-Venzel thingy. So is that some random guy on the internet that's seemingly providing images that will try to hack onto your systems? Fear not. That guy works for Oracle. That guy is my manager. So we still keep it in-house. So the reason why we posted this, started here on GitHub instead of going into the official way, is that it takes a while to go into the official registry. So we wanted people to have access to the images as soon as possible. So that's why they are here. These images, by the way, are the ones used by Spring teams to test out their Oracle implementation. And the same goes for Quarkus and Jakarta and everybody else. So if these images are good enough for those open source projects and you happen to consume those projects as dependencies for creating your own solutions, then we hope that these images will be good enough for you. Now, going back to test containers. Test containers provide modules, dependencies for all the different databases. So there we have CockroachDB, MariaDB, MySQL, Postgres. There are 2 modules for Oracle. There's the Oracle free module. So this is from 23 onwards. And there's Oracle XC module. What is the difference? There's a tiny set of properties that you have to configure in one versus the other. So instead of you having to reconfigure XC to work with 23 onward, we decided to provide a module for 23 and onward. So many things easier. How easy these things look like? if you configure a Maven dependency in your project, so this will be Testcontainers Oracle free, then the only thing that you have to do in your source code in your test case is initialize a new Oracle container pointed to an image of Oracle free. This may be one of the images that we saw from Gerald Wenzel, or an image that you may have repurposed yourself, and then just start the container. That's everything that you have to do. I'll show that in the demo. Okay. Another thing is that obviously we're talking about Java and we need access to the drivers. Does anyone here recall the time when we needed to download the drivers from the OTM page and probably put it into an artifact repository, or even check in the jar files into source control? Luckily, since September of 2019, we don't have to do that, because the drivers since that time, so close to 6 years ago, they're finally available in Maven Central with a new license. So you can use it just like any other database driver out there. So all the complications in the past are gone. There is a new group ID that you have to use. It's called Oracle Database JDBC. And there's a bunch of dependencies out there. The one that you likely would like to use is OJDBC 11. That is the version of Java that your server will be talking. There's another version, it's called OJDBC 10 and OJDBC 8. If you happen to be on 8, I will encourage you to migrate to 11. Now, there is a guide for consuming all the different artifacts in both Maven and Gradle. So there's the driver, there's the connection pool, and if you want to connect to the cloud version of the database, there's an additional set of dependencies for handling authentication, security, encryption, and other formats. So this documentation will explain everything that you need to know about connecting on the on-premise database containers and also on the cloud version. All right. Now let's get into the demo. Let's see. I have everything set up in IntelliJ. So what I have here is a trivial Spring Boot application. The only thing that it has, is it visible? Hope so. Okay. So there's just a simple domain entity. There's nothing strange about this one. As an ID and just 3 properties, getters and setters, nothing surprising. There is a customer repository that will give us CRUD access to that entity. And I decided to add 2 additional finders just for fun. And you know that you can add custom queries, native queries. You can go crazy with how you can do things, or simply leave the repository empty and have the default settings from the CRUD. It's up to you, whatever you have to do in your particular application. And my application, it's empty, because I'm not going, it doesn't care much what this application will do. It's actually how we're gonna deal with the entities, the repository, and how we want to test this. Now, I need to showcase in the POM file some of the dependencies that we have. So this project, I just recently upgraded. This, I believe, is not the latest version of Spring Boot. So it's still running a few versions behind, but should not be much of a problem. So I'm starting from, let's see, I was using Java 17. Anyone here using 21 already in production? Just a few hands. Okay. Let's wait for 25 come out this September, so the next LTS. I do have, one of the things that Spring Boot does is provide managed versions of many dependencies. And they do manage the Oracle dependencies. I believe that this particular version of Spring Boot has an older version of the database for Oracle. So that's why I'm using this property here to change the version number. This is the latest one that is available in Maven Central. I could do the same thing for Hibernate. I think Hibernate 7.0 just came out a few weeks ago, but I'm still relying on 6.6.1. So what else do we have here? I have a dependency on the Spring Boot Testcontainers. I will show you in a moment why I have this one. This is a recent addition, at least for this demo. Or Spring Boot still manages Oracle database. The drivers, they use JDBC 8. I want to use 11, so that's why I explicitly list this one here. I will showcase DbUnit. The latest version is 2.80, sorry. There's the version for Database Rider, and some dependencies for Testcontainers. So there's one for Oracle database. This is the one for the Oracle free module, so 23 onwards. And I had another demo that was using Postgres, but I'm not going to showcase Postgres in this moment. And I think that's everything that I have to do. So it's just a handful of dependencies, not much. And of course, make sure that you're using the right scope. Don't put it in production scope. Don't put compiler runtime. These have to be test scope. Okay. Now, let's see the first one. So if you were to use DbUnit and Testcontainers together, you'll find soon, and Oracle, you'll find soon that you have to write a few things. So we start with just a regular Spring Boot test, like everybody else. We'll create a new instance of a container. So just because I have that Oracle free module from Testcontainers, I can create an instance of Oracle container pointing to that particular version of the image. If I wanted to run the latest, this will be 7. But we will be at the mercy of the network. So I already have a local version of the 23.6, so I'm going to use this one. And because I don't have any explicit management for this container, I have to manually start the container and shut down the container. So that's the reason why we have these two annotations and these two methods here. Before every test method, we start the container once, and after all the test methods have been run, we stop the container. Then the other thing that happens here is that because that container is going to start with random ports and random username and password, we need to grab those credentials and put it inside the dependency injection container. Otherwise, the data source will not be able to be set up. So we're using this thing, which is the old way to do things. We use a dynamic property source to read the properties from the container. So that Oracle container will give us the properties, and we'll put it inside the dependency injection container. We have some, we auto-wire the customer repository, auto-wire the data source because we need this data source for DbUnit to work. And then we use this thing called the iDatabase tester. It's an implementation of something that knows how to talk to the data source. And I had to create my custom database tester. Why? Because this particular version of DbUnit does not understand the Oracle dialect. If you were to use Postgres or MySQL, you probably don't have to use this. So the only reason to create this tester is to set this specific property right here. That's the only reason. Okay, so the rest of what I do in this test case is ensure that the database tester can read some data set, this external file that defines the data set, before each test method, and after each test method, will perform some operation. This is where you can do automatic verification of the data, or you can do automatic rollbacks or delete everything. It's up to you to decide what this is going to do. In this case, it's going to delete everything that was inserted coming from the default data set that you provide. And some additional methods here to read a data set coming from an external file. This will be an XML file. So this is, again, is just plumbing code. Because what we want to do is this, an actual test method. This first test method, what we're doing here is ensure that Spring data works correctly. Why? Because we're querying a set of elements in a particular table. That will be the customers table. And depending on the data set that we gave it, it will have certain amount of rows. So if that is correct, we will have at least 2 rows of two customers that have the Doe last name. I'll show it in the data set in a moment. And in the second test method, what we're doing here is we're creating an instance of a customer, save it in the database, so we will insert a new row. We expect now to be how many rows? To have 3 rows. Then we grab the data set from the external data source. Then we grab the data set from the real database. Now we have 2 data set objects, and we're going to do a comparison. We're going to do a diff. And if that is the case, if these things are equal, we're good. If there is a problem, then this will tell us. What is the data set? Here we have it. Well, I don't have. So it's just a regular XML. This is the short version. The name of the element will be the name or matches the name of the table, and each one of the attributes matches the name of the columns. You might be wondering what happens if I have values that are not valid characters that you can put as attribute values. Well, that's when we use the expanded XML format, where you have an XML element that says customer, then another XML element inside that will be ID, first name, and last name, and you can use character data for that. Okay, so obviously for this trivial example, this data set is small. If you have your production environments, you have much bigger data sets. You can do things by hand, or you can use the DbUnit feature that I told you earlier before, that you can export data precisely in these formats so you don't have to manually write everything. And once you have exported the data, you can, of course, change everything you want to. You can also exclude certain columns that you don't want to be filled into. Now, there is another data set, which is the one that we will compare once we have added something. So when we expect to have 3 rows. Okay? So let's run this test case first. Let's see what happens. There we go. We expect 2 test methods to be invoked. And we have 2 green test methods. Yay, do you trust me? Never trust a test you have not seen fail once. That means we're going to make these test cases fail to see if that's actually, they're testing the right thing. So our input data set says I have 2 rows with 2 last names that match though. Let's see, that's where our expectation here, right? So let's change this to 3. Now, when we added a customer, we added this row here, and we add Joe Cool. So let's change that to Joe Hits. And let's rerun these test cases, and now we'll expect these 2 test cases to fail. One of them will fail because the expected number of rows is different, and the other because we did not find the correct set of matches. So this one does tell us this is just a regular assertion from DbUnit because the size of the collection is different. Okay, but notice now, when we do the assertion on DbUnit, it tells us that the value is different. We were expecting cool, but actually it's hits, but from which table, which row, and what column is different. So a little bit more helpful. Great. But as great as this database is, this test case is, it's a lot of code that we have to write ourselves. We don't like that. We would like to do things better. So let me show you Database Rider. This one, we add 2 additional annotations. We add Database Rider and Testcontainers. We also add the container annotation here. So this will allow the test case itself to do the management of the life cycle. So gone is the before all and after all that we have to start and stop the container, because that will take care of by these 2 annotations. We are still using the dynamic property source to ensure that we can grab the random values from the container to be set up in the dependency injection container. Gone is a database tester. We don't need it because we're using Database Rider. 2 additional things now. We have an input data set and an expected data set as annotations. And in this case, you can see that the input and the output are exactly the same, because for this test case, we only reading data. We are not expecting any mutations of the data. So if the data changes, that means there's some problem in the Spring data. And for the second test method, when we do the insertion, well, we'll simply insert the entity, save it, and we're done, because the input data set and the expected data set are different. So this will take care automatically of doing the validations that we did by hand. But you notice that the input file is different. It's no longer XML because we are now in modern times. We now hate YAML. So there's the input document. So this is just a list of values and the key values. So the first one, the name of the table. And then the keys will be the names of the columns, and the values will be the values for each column. So for the added elements, we will see it exactly like that. It's again 3 different rows. So this should be good. Okay, let's run this one. And let's see what happens. We should have 2 green test methods. So there's the application running. These are additional output coming from Database Rider. So in case that you wanted to have additional this additional metadata that prints out when it connects to the database, in case that you were wondering about that. So our two test methods are fine. Okay, we can make this fail again in a similar fashion. Let's say now this is 1, and this is Bengaluru. And let's rerun this. And now I will expect these two test methods to fail. This should be fail, and now fails as well. This one fails because the size is different. It's 1, but it was actually 2. And this will fail because on the table customers, the first row, column last name, we're expecting cool, but it actually got Bengaluru. Great. But we can do better than this. In Spring Boot 3.1, they added a new annotation called service connection, which removes the need to use dynamic property source. So this test case that I have here is the shortest test case that you can have. The only thing that I had to add now here was service connection annotation. And gone is the need to use that dynamic property source. So our test case is quite minimal now. It just looks like this. And I can happily go again and run this test case, and these two should be green. First one, and done. So it's as easy as that. Okay. I think that takes care of the demo. Any questions that you may have on the demo? Yes. Okay, so the question is, if the reason why we're using Testcontainers is to provision the database instance. Every time that we run this test case, there is a new instance of the database with a pristine environment with random ports. So that way, if you want to run test cases in parallel, there's less chance of things breaking down because you may be using the same ports. And the reason why we use Database Rider is so that we can add the data before the test method is invoked to the database, and also automatically verify the data once the test method is has finished execution. That's the reason why here, when we do the insertion of an entity, we don't care what entities may be already saved in the database. But once this test method finishes, using this annotation, DbWriter will automatically check and grab a snapshot of the database and a snapshot of this external file and do a comparison. And if they happen to be equal, then your test case is green. If it's not equal, then obviously there's something wrong, and it will tell you where it was. So the reason to use Database Rider is to have these capabilities, but also modern capabilities for JUnit 5 and modern Java. Because if you were to use DbUnit, you would have to do these validations by hand. Let's do DbUnit. Because the other database Rider, the difference was the use of the service connection. So let's do this one here. Now, I have to say that, okay, he's running. That, so we make this fail, right? So it's about the same size. That, yes, and this is exactly what I wanted to say. Given that the database can now run on ARM chips, we are able to run the Oracle database on smaller devices. How small? You can run this database on an on a Raspberry Pi. There's a few changes that need to be done in order to do the setup in the configuration, but it's doable. Now, would you run this on production on a Raspberry Pi? Not necessarily. Depending on if you're doing some sort of embedded environment, maybe. But this showcases how slim and how fast and how things have changed now since you last looked at Oracle. Oh no, you can use DbUnit and DbWriter with a huge amount of data if you want to. It's just that if you want to use externalized data sets, then depending on how big your tables are, then you have to write a lot of XML. Then you would use the mechanism to export the data set into XML and do the manual modifications. Oh, yes, certainly. And you can also, with both DbUnit and Database Rider, instead of using externalized datasets, you can use the programmatic API to create the datasets. Why would you like to do this? Any one of you have heard of a library called Data Faker, which allows you to generate fake data given certain form. For example, you can generate credit card numbers or phone numbers or addresses or names, license, and whatnot with this Data Faker library. But of course, it works in programmatic APIs. Now, you can create a data set, everything using just the API using the program. And once you have it, just supply directly to DbUnit. Or additionally, you can also grab a copy using an external file and then inject with Data Faker values in certain columns when you want to have something programmatically, and then supply that to the database. And this is completely separate of the amount of data that you want to deal with. Yes, you could have an external data set, a external database instance. So for that reason, you will not use Testcontainers. You will just use regular Spring Data or connection pool to connect to that external data. And you can continue to use DbUnit and Database Rider to put data into that database you want to, or do the verifications. So I'm showcasing all these technologies together to see how you can condense as much as possible to have a pristine environment, but that nothing stops you from just using one or the other, separate from each other. No, there's no limit. There is as your instance will support. In the case of running the Oracle container in this way, the limit will be the amount of memory you have access to. Yes. Yes. So the question is, what happens when I have multiple test cases with multiple container classes? Well, not a problem. If you run your test cases in sequence, then the containers and all the test cases will be executed one after another, so memory will reclaim at the right time. If you happen to run this in parallel, then your limitation will be memory. Because if you set your test case in this way, then the database will be starting in random ports. Hopefully, there will be less opportunity for a collision. But it might happen. But you will still be limited by how many of these test cases you can run in parallel. Does it support the testing frameworks like TestNG? DbUnit does run with TestNG. The Database Rider, I'm not so sure. And Testcontainers, I think they might have looked into it in the past, but most people nowadays use JUnit. There are still a few people, there are a few organizations that run TestNG. There are some features that TestNG provides that JUnit does not. But most of the people have migrated now to JUnit 5. So does the Oracle container runs on emulated mode or native mode? Well, it's just it's a software that runs on a regular container. So it is just running on that. I guess well, it depends on the image that you run, that you define. The images are multi-platform, multi-architecture, if I'm not mistaken, the ones provided by Gerald. So if you want to run a container on Intel or a container on ARM, the same image will do the job for you. Mm-hmm.
I can start on state of container outside the test classes, like for multiple test classes again at Bitcoin. Like I can start the container and then run set of test classes and then we get shut down the container.
So the question is for the recording is a possibility to start the container outside of my test classes and then shut it down after all the test classes. I guess. I mean, one way to make it work, I was about to say fake it, is to have like a base class, an abstract class that does this for you, and everybody will have to extend from this one. and you have to deal with the static fields and whatnot, it starts to sound a bit more problematic than just letting test containers do this. There might be reasons why you want to do this. It could be the case that the particular software that you're using takes longer to start, or the setup. So for this reason, it may be better to not necessarily use a container in this way. But you will probably have to use your build tool to do the setup. And I think you may still be able to rely on test containers to do this, because test container is a library. And so you use test containers within Maven or Gradle to start your container before the test step, and then ensure that you have the right hooks in your build tool to do the shutdown after the test step is done.
The bad thing.
Yes, exactly.
And the containers expected that expected YAML only or it support JSON.
So the question about is what is the format for the expected data set. For Database Rider, I think they support XML, but they added support for YAML because it's less verbose. What about JSON? I don't think it's supported. That would be probably a nice addition. So both Database Rider and DbUnit are open source projects. So if they don't support a given format and you would like to have support for it, TOML is another possible option, or even CSV. First, have a look at the issue tracker, see if someone is working already or has added an issue for it. And if no one is working on it, and if you happen to have the time, maybe you or someone else can help us deliver this feature for the open source project. Yes?
I can check that they're reporting I could stop it, but the kids start. I got up the water in the country. They thought somebody took the price industry, but they already get everyone of that part of the but they are my people. They take up to be they don't.
So the question is, there any other library that I could add to my test cases to have some additional reporting like what we see here? I am not aware of those. There's likely to be one there. I mean, there's so many things about Java that there's always a jar for it. But unfortunately, right now, I can't give you a straight answer for a given name. But TestNG will give you the reports for that. But then the question now will be, can we run Testcontainers, Database Rider, and with TestNG? That will be one thing to find out. Any other questions?
Does it support re-entrant lock?
Does it support re-entrant locks?
Not re-entrant lock.
Well, so Testcontainers doesn't really care about that. So that will be, well, it's specific to the database software. Well, that will be specific to the software, the database that you're using. So in the case of Oracle, that shouldn't be a problem. But if you're using another database vendor, then you'll have to consult the documentation for that one. All right. Do I have the software available? I don't have a repository for this. I should put it out in a public URL. I guess what I will do is put it in the public and send a message to the organizers of the conference, so I will send it back to you as well. Or you can connect to me on LinkedIn, and I will give you my details, and then we can continue the conversation. Let's go back to the slides. All right. So what about the future? Well, some of the things that could happen is perhaps additional support for other formats in Database Rider. Figure out better support, integrate support with Data Faker. So right now, if I were to showcase a demo of doing Database Rider and Data Faker, it will be quite verbose. I hope that it will be an easier way for me to say, I want to combine these external sources with these other things that I'm just generating right now, and boom, it just happens. Those are the things that could happen. Now, in the specific case of Oracle database, one of the things that I would like to have is better integration with CI/CD pipelines. If you happen to use GitHub and you cannot run test containers for whatever reason, and you still want to use a database, then there is a GitHub action called Setup Oracle Free. This one is just a simplification of how to run a container service on GitHub. You can run any software as part of a container on GitHub very easily. It's just that setting it up is quite verbose. So what with this action is to simplify all the things. So if you're running on GitHub Public or GitHub Enterprise and you have access to GitHub Actions, then you can set up an instance of your Oracle free database, 23 onwards, and then connect it. So this will be akin of running an instance before everything. So instead of using the build tool, you will use the CI pipeline to set up that instance. That will only start the database for you. You still will have to shut it down. Or once the CI pipeline is done, then that will kill the container as well. We would like to support in the future also set up for GitLab CI and Jenkins. But we started with GitHub because that's what we've seen that most people use. So my name is Andres Almiray. I'm a Senior Principal Product Manager for Oracle. I'm an open source developer at heart. I've been doing this for many, many years. I'm a contributor to DbUnit. So you saw that interface called iDatabase Tester and these few instances, implementations. That was my original contribution to DbUnit. In the past, you had to extend from a database test case and continue the hierarchy. With the iDatabase Tester, then you can use composition. I'm a Testcontainers champion as well. I'm a Java champion alumni. I really love to talk about open source, and this is one of the reasons why I'm back here at HITS and to be with you and share these experiences. You can find me as A. Almiray on GitHub, on LinkedIn, on Blue Sky. I have a Mastodon as well. Twitter account, I don't use Twitter anymore. I'm just pretty much search for Andres Almiray, and you'll find my face over there. I also want to say that there is an Oracle user group tour coming up. This happens almost every single year here in India. So these are the cities and the stops that will happen in July, late July of this year. So if you want to know more about other Oracle technologies, not just the database with Java, Linux, APIs, and whatnot, this will be the place for you. I believe that entrance is free. You just have to register. And if you're close to one of these cities, then it will be great if you can participate in that one. Now, here are some additional resources of the things that we saw. So Testcontainers, they have a bunch of modules and things that you can see inside. And they have a community in the Slack where they can answer questions. There is the link for DbUnit. As you can see, it's quite old because this uses SourceForge instead of GitHub. Whereas Database Rider, they have migrated to GitHub. And in the case of Oracle resources, there is a web page for a lot of things that are free, available for developers. It's not just Java, the database, and Linux, but other things. There's other projects and other products that we can use for free without any problems. The second one is the sign up for the Cloud, the free edition. The third one is where you can download the free edition for all the database that you can run on Linux, Windows, and Mac. And the last one is a set of workshops that you can also run for free with a lot of other technologies. There's Micronaut, there's Spring Boot, there's Quarkus, there's Plain Java, and all of things that. So all these resources are completely available to you at any point in time and always for free. So I think this is all that I have for you. Thank you very much for listening.